Hi everyone! In this video we're going to start discussing alkanes, which are our first class of organic compounds. So alkanes are really simple carbon-containing compounds. If you've ever grilled with propane before, that is an alkane, and the structure of propane is shown off to the left here. And again, the main component here is carbon. So on the periodic table, carbon is element number 6, but we'll review carbon later on. So let's dive into a little bit of history here. So early on in chemistry, chemists thought that organic compounds were produced from living things or living organisms, and that they were produced through a vital source from these living organisms. However, in 1828, a scientist by the name of Friedrich Wöhler first synthesized an organic compound from an inorganic source. So an inorganic compound would be something, at least back then, that came from a non-living organism. So what Friedrich Wöhler did was he took a compound called ammonium cyanate, NH4NCO. And he added some heat, and he was able to produce something called urea, which is found in the urine of mammals. So he took something that was inorganic or thought to be non-living and made something organic, which back then was thought to be from a vital source or from a living organism. So what Friedrich Wöhler did was he discredited the vital force theory because you can synthesize organic compounds from inorganic compounds. So then the whole idea of organic chemistry changed. So now we considered organic chemistry as the study of carbon-containing compounds. So pretty much anything that contains carbon is considered to be organic. And this isn't like the organic food at the grocery store, right? This is just anything that contains carbon. Inorganic chemistry, on the other hand, will study elements and everything else. So, for instance, maybe you're studying bromine or iron, a different element other than a carbon-containing compound. So the principal components of things like the food we eat, fuels that we use like propane, wood, and clothing are organic compounds. So organic chemistry is really all around us all of the time, which is why it's really important to study it. So there are an estimated 500,000 inorganic compounds that have been identified, but there's actually more than 9 million organic compounds that are known. So each year we're also finding thousands of new organic compounds, or we're synthesizing them from some other source. So organic compounds are much more abundant in nature. All right, so let's look down below at some properties for organic and inorganic compounds. So, for example, let's talk about bonding within molecules. So organic compounds typically have covalent bonds between atoms. And what is a covalent bond? Do you remember? So remember, a covalent bond involves sharing of electrons, right? Now, inorganic compounds, on the other hand, are often contain ionic bonds. Do you remember what ionic bonds are? So that's where we transfer electrons from one atom to another. All right, so let's talk about forces between molecules. So if we have two organic compounds next to each other, because we don't have ions typically that exist there, the bonds between organic compounds, or the forces, I should say, are more so hydrogen bonding, dipole-dipole interactions, or van der Waals forces, which are really, really weak. So the forces between molecules in organic compounds are generally weak. Inorganic compounds, because they have ionic bonds, they often have very strong interactions with other inorganic compounds. So ionic bonds can be really, really strong. All right, let's look at the next category. What is the typical physical state? So is it a gas, liquid, solid? So organic compounds can really be anything, gases, liquids, or solids. Although typically if we have an organic solid, it will have a really low melting point. But again, you can have liquids, gases, or solids there. Inorganic compounds, on the other hand, are usually solid, and they typically have a pretty high melting point. And we'll talk more about melting points in our first lab next week. All right, so now let's go on to flammability. Organic compounds are, again, made of a lot of carbon atoms. So for instance, propane is an organic compound, and propane is very flammable, and that's pretty true for most organic compounds. They're often flammable. Inorganic compounds are usually non-flammable, and again, that's typically because they're really high melting point solids. And solids can be hard to burn, for instance. All right, so let's talk about solubility. So solubility refers to the ability of something to dissolve. And in water, organic compounds typically don't dissolve. So this would be, for instance, like oil and water. They just don't mix. And most organic compounds are more similar to oil. So they don't really like to mix with water. Whereas inorganic compounds might be something like a salt, like sodium chloride, for instance, and those will dissolve pretty quickly in water. All right, so because organic compounds don't really dissolve in water, they're also considered non-conductors. But inorganic compounds can dissolve in water typically, so they are considered conductors. So for instance, if you dissolved sodium chloride in water, you could form a connection with a battery and some electrodes and see that electricity is generated. Whereas with organic compounds, that just doesn't occur that often. It really depends on the organic compound though. Rate of chemical reactions is our last category here. So the rate of a chemical reaction that occurs with organic compounds is usually really slow. So often we need the help of a catalyst. And a catalyst is something that will lower the activation energy of a reaction. But inorganic compounds typically have a fast reaction rate. Okay, so let's talk a little bit about what to expect this quarter. Organic chemistry is very different from general chemistry, or sometimes that's called inorganic chemistry. There's very little math in organic chemistry. I still recommend having a calculator handy just for those few times that we will need one. But the main types of problems that we'll come across this quarter are naming compounds and drawing structures. So we'll learn how to name organic compounds, which can be tricky at times. We'll also practice drawing compounds for organic chemistry. We're also going to describe physical properties of substances. We'll also practice writing reactions, and we'll also be able to identify the typical uses of compounds by the end of the quarter. And of course, we're also going to incorporate some biochemistry into our discussions later on this quarter. So we're going to talk about, again, structures of biochemical molecules, their purpose, their function, why they're important. So we're going to cover all of that this quarter. Now, I'm going to end the video here since I just wanted to kind of introduce the topic of organic chemistry. Next time, we're going to dive back into some atoms and elements. So we'll review carbon, and we'll talk about how it bonds with other atoms, since that's really important in organic chemistry. So I will see you then.